Okay, so let's find the optimal order quantity for the NFL jersey problem using a data table. So I'm going to set up a data table, and the version I'm going to show you is in Excel. And this is attached to the unit if you want to follow along and see how the spreadsheet's set up. There's also a version of LibreOffice in there as well. All the functions are the same. Data tables are a great way to test and see different relationships for an equation. So all we're going to do here is try for different values of X and Q, the demand and the amount that I order, what the profit function tells us. What's the profitability if I order a certain amount and a certain demand materializes. So what I have here is my spreadsheet, and up in cells B, 2, and 3, up here is the demand distribution. Now I put all of my demand in units of 1,000, so my mean is 32,000. Units over the 8-week period with a standard deviation of 11. I've got my price per unit, $24 per jersey. $10.90 is the cost per jersey. And then I have each of the columns is a potential order size. So this column is saying, what if my order size is 24,000 units, right? This column is, what if my order size is 27,000 units? Then I've got each row, and each row in my data table represents a demand that materializes. So for example, this row, let me see if I can circle that, is what happens if 2,000 units of demand materialize. And down here, this row is what happens if 20,000 units of demand materializes. So each cell is essentially an instance where I look at a certain quantity was ordered, in this case 25,000 units, and a certain demand occurred, 4,000 units. So this cell, which is cell E8, is essentially telling me what is the profitability if I ordered 25,000 of these jerseys, but only 4,000 units of demand showed up. And all that this is in this cell is this profit function up here. And it's just tied in to the quantity and to the demand. Now, this is for each instance. I now need to figure out, well, how frequently will that happen? And so what I've done for each one of these instances of demand, because that's what's random, right? The demand is random. The Q is something I'm going to pick. I'm basing this off the normal distribution. So here in column A, what I've done is the cumulative normal probability. And so you see I'm just using the norm dist function that we've seen before. And so for this cell that I highlighted, it's simply saying what is the cumulative probability that I will receive, that my demand will be at least 8,000 units or less. And that's going to be 1.5%. And that's based off of the mean of 32,000 and the standard deviation of 11,000. Then all that I do for the probability that each of these demand values occur is the difference between the two cumulative values. So look at the spreadsheet and you can see how that works. But the net effect is that each cell tells me what the profitability will be given a certain demand and a certain order quantity. Now here's what the whole spreadsheet looks like, or a larger piece of it. And again, I've got each column, right, is one demand quantity. So the one that I just highlighted is where I ordered 24,000 units. And then each row, again, is the demand that materializes. So that first row, row 7, shows all the profitability if only 2,000 units of demand materialized. So I have that for a bunch of different demands, and you can see that the probability for those go up to 100%. So I go up to 70,000 units, which is pretty unlikely to get. And then what I'm doing here is I want to find out, well, what's the expected probability if I order a certain amount? So for this column, column E, which is when I order 25,000 units, I have each instance here, but I want to find out what's my expected profitability. And that's simply going to be the sum product of the probability that each one of those demand values happen, right? And that's going to be multiplied by the profitability of each one of those occurrences. So this sum product is essentially finding the expected profitability if I order 25,000 units. And so if I look across here, you can see that as I increase from 24,000 all the way up to 33,000 units, that profitability is increasing, and it maximizes when I hit right around 34,000. You see I highlighted it green down here. And then you can kind of see as I increase further, as my queue gets bigger, my profitability starts dropping off. And so what I have here is I actually mapped this and charted this. And so along the horizontal axis is simply row 5, which is the order quantity. And along the vertical axis is that bottom, row 42. Let me just go back here. This row down here, right? This bottom row that shows me the profitability for each order quantity that I have, right? So this is row 42 from the spreadsheet. And it's just showing my expected total profit. And as it showed, is the total profitability increases peaks out at a certain point and then decreases. And so the area to the left of that optimal quantity is where I ordered too little. And over on the other side is when I ordered too much. And so what we're finding here is the data table is helping me find the zone where that order quantity will be maximum. And so data tables or data spreadsheets are great ways to explore a problem. What we're going to do next is look at the marginal analysis to find an analytical form for finding Q star.